this is the second last lecture of this semester. And the last lecture will be on Wednesday, which is a review lecture. And today, I'm going to briefly describe, tell some non-technical details for the ChatGPT models. So first of all, let's go through some logistics. So all contents of this lecture won't be on the exam. So you don't need to memorize the details, like how large those models are and what data sets these models are trained on, and how well they perform. And also, so all of these contents won't be on the exam. And assignment 3 is due soon. And for assignment 3, there are some questions for the auto model for causal language modeling questions. So if the accuracies are low, like getting 2 out of the 5 sentences right, 1 out of the 5 right, or even 0 out of the 5 right, it's okay. So don't worry about the accuracy. There's no expectation of what accuracies are supposed to be reached for those questions. So actually, for the auto model for causal language modeling, some students point out that the default behavior for transformers version 4 actually loads the math language modeling head instead of the causal language modeling head. So if you load the GPT-2 based case model rather than the BERT-based case models, then the accuracy could be higher. But for the assignment 3 of this year, we do expect to load the BERT-based case model, and it's actually expected to see some low accuracies. And overall, don't worry if the accuracies are low. So the low accuracies are expected. So let's start with asking ChatGPT to help me write an introduction to this lecture. In a welcoming tone, write a short introduction for an NLP lecture that introduces the development history of GPT models. Here's what ChatGPT writes. At the end of this lecture, you can decide yourself whether this introduction makes sense or not. Welcome to our NLP lecture on the development history of GPT models. In this lecture, we will explore the evolution of GPT models from their early beginnings to the current state-of-the-art models. We will discuss the key milestones and breakthroughs that have contributed to the development of these powerful language processing tools. By the end of this lecture, you will have a better understanding of the history and progression of GPT models and their impact on the field of NLP. Let's begin. Here's a brief timeline of GPT models. The earliest occurrence of GPT was in 2018. We OpenAI released the generative pre-trained transformers. At that time, GPT was not really the highest performing model, and the most popular candidate at that time was called Elmo, and it was a bidirectional long short-term memory proposed by a trained by Allen AI. In 2019, OpenAI trained the second iteration of GPT model. It's called GPT-2. Unfortunately, GPT-2 was still not the most popular model at that time. The most popular candidate at that time was called BERT by Google Research. And interestingly, the lead author of the BERT paper, Jacob Davlin, recently left Google for OpenAI. So that was an so the world is interesting. It changes fast. In 2020, OpenAI released the third iteration of GPT model, and this time it really made the headline. GPT-3 paper by Brown et al. Won the Best Paper Award at New York's conference. And more importantly, GPT-3 paper proposes a new learn by prompt paradigm that greatly shifted how natural language processing and machine learning researchers do the research. I'll explain the prompt learning paradigm in a few slides. OpenAI didn't stop there, though. In 2021, they released a series model that tried to further improve upon the GPT-3 models. So this includes InstructGPT and Codex. Codex uses both programming languages and natural languages to help the input of the language models more structured. And InstructGPT uses human alignment to make the behavior of the GPT models more aligned to the human's expectations. OpenAI didn't, okay, so OpenAI really recently put together the advances of GPT-3, Instruct, and Code together in the end of 2022, and they released a ChatGPT model. And Chat is the model that you have probably heard several times on the news in the past few months. So there are no fundamental differences between the technologies that OpenAI already used and the technologies that are used to develop ChatGPT. So the success of Chat is, in my opinion, the result of massive engineering effort and painstaking execution of those details. So let's take a look at the backbone that GPT models operate on. This is the unidirectional transformer decoder. So by unidirectional, I mean that the representations at every single location are computed based on both the representations at that step and the representations at the previous steps. So nothing that comes from the future are passed into the computation of the current representation. So this makes this kind of transformer decoder part very suitable for doing the decoding. Because during the decoding, you actually don't expect to know anything that comes from the future. So this is also part of the reason why this part of the model is called the decoder of the transformer. So remember that in the natural language understanding lecture, I masked out the right-hand side of the transformer and said that one was GPT. So, so this architecture is the overall architecture that was masked in that slide. So the left-hand side of the transformer is the transformer encoder, which was used in BERT model, but the transformer decoder was used in GPT models. So how was GPT trained? There are two objectives. There is the language modeling objective, which tries to predict the token that comes after this sequence. There's also the multitask fine-tuning objective. So OpenAI trained the GPT model plus a classification head on multiple supervised learning tasks. And at every single task, they use a new classification head. So the previous layers are shared, whereas the top layer or the classification head is unique to every single task. So in this case, so by doing this type of multitask fine-tuning, OpenAI hopes that the GPT models, for the lower layers of the GPT models, handle the common patterns across the tasks. And the last linear head is very task-specific, and they discard them anyways. So this is the training objectives of the GPT model. But there is a problem. The pre-training data is a lot less expensive than the data, supervised learning data that are used in the fine-tuning. And also because the GPT models are evaluated on the supervised learning data, so they don't really want to put we don't really want to put the supervised training data into the multitask fine-tuning, because this would possibly result in data set contamination or the sort of training on the test set problem. So pre-training is actually a lot more desired, a lot more preferable than the multitask fine-tuning. So this is what happened in the second iteration of GPT. OpenAI decided to only keep the language modeling pre-training objective. So they try to maximize or minimize the loss of predicting the next token based on the existing tokens. So the intuition is that by modeling the language, this model learns to simulate the language. And at the same time, because language is a tool that's used by humans, and humans use this language to to convey complex thoughts. So if there is a model that can model the language, it can also model the complex thoughts and could also be useful for encoding the knowledge that are transferred from humans to humans using language. So this is an intuition that drives OpenAI towards only keeping the language modeling objective. And also, the corpora sizes differ. The dataset size that were used by GPT-2 were around 40 times as large as the size of the dataset used by training GPT. So GPT-2's dataset size was around 40 gigabytes, but GPT was around 1.1 gigabytes. Regardless, the GPT-2 was already able to produce high-quality generations for languages. You can provide them with a context and expect GPT-2 to continue writing the story. Here's a context that are shared by in the appendix of the GPT-2 paper. So in a shocking finding, scientists discovered a herd of unicorns living in a remote, previously unexplored valley in the Andes Mountains. Even more surprising to the researchers was the fact that the unicorns spoke perfect English. And here's what GPT-2 generated. The scientists named the population after their distinctive horn, Ovis unicorn. These four-horned silver-white unicorns were previously unknown to science. Now, after almost 2 centuries, the mystery of what sparkled this odd phenomenon is finally solved. Dr. George Perret, an evolutionary biologist from the University of La Paz, and several companions were exploring the Andes Mountains when they found a small valley with no other animals or humans. Perret noticed that the valley had what appeared to be a natural fountain, surrounded by 2 peaks of rock and silver snow. Perret and the others then ventured further into the valley. By the time we reached the top of one peak, the water looked blue with some crystals on top, said Perret. So you can see that the story actually are very coherent. It almost looked like the story that you will see on the newspaper, except that most of the information comes from hallucination. At that time, researchers were mainly using GPT-2 as a language generation tool. So whatever we give the language generation tool is a context. We essentially set the stage. We specify the topic, specify the background information, and specify what we want the generated contents to be. Essentially, we are letting the GPT-2 to continue writing a story after our context, within the context. But later, people found that there is a more ambitious paradigm than the context and generation than the generation following the context paradigm. This is the generation after prompt paradigm. So in the prompting paradigm, you are interacting with the language model as if the language model is a smart assistant that can understand your command. So in the prompt, you just give the language model some commands or some demonstrations, which are some examples that you show the language model what to do. You can also give them some descriptions, which are telling the language model what to do in natural language. And in the generation returned by the language models, some highly capable language models are able to respond properly to the prompt, but not GPT-2 though. Here's an example of prompt-based system. You can pass in some questions in a prompt format, and this format is essentially just asking the model to continue generation after an incomplete description. And this incomplete description, this incomplete sentence prompts the model to generate the answer. And this example is one of my favorite examples. This comes from the Winograd Schema Challenge. An elephant can't be put into the fridge because it is too large. What is it? An elephant or a fridge. In order to correctly tell what it is, you need to be able to utilize some common sense knowledge. And here, the piece of common sense knowledge that is useful is that the elephant is usually a brown, large mammal that's usually much larger than a fridge. That is usually the household device. And let's take a look at what GPT-2 generates. It essentially generates some nonsense. So it says the answer is that I had an elephant in my fridge while eating dinner at my family holiday party with my. So GPT-2 was not able to directly answer this question based on the prompt-based. If you prompt with the question. But some people realize that you can show some examples in the prompt to improve the performance. So before giving the large language model the question and the prompt to answer, you can give them one or several examples. So here, this is the this is called one-shot demonstration, which is you give them one demonstration, one example before asking the language model to continue writing and answering your question. So during this demonstration, we are actually telling the model what forms we are expecting it to generate. So for some language models, if you pass in one-shot or few-shot demonstrations, it is possible to just return the correct answer. So the examples don't need to be very similar to the question. So the question is about what it refers to, whether it's an elephant or a fridge. The example don't need to be the pronoun resolutions of between an elephant and a fridge. It can be, for example, the computer is too large to put into the case. What is the computer? What is it? The computer or the case? The answer is the computer. Or the example can also be the same window graph schema challenge question, but elephant can't put into the fridge because it is too small, and the answer is the fridge. So there are still there isn't a fixed set of rules for selecting what examples to put into the demonstration. So properly selecting the examples for including in the demonstration could lead to significant performance boost for the large language models. But this area still remains unexplored. And yeah, question?
Yeah, for, like, when we're talking about like one-shot demonstration, does that one-shot goes into the training set, or are we just like?
We're just using the large language model as is, so we don't train the large language model anymore, and we just prompt the model after the model is trained. So everything is about the inference. It's not about training the language model. So this is the key difference between the prompt learning paradigm and the previous paradigm. Yeah, question?
Would this whole thing be in one single prompt that we provide, or?
Yes, one single prompt.
But are there models where the first, like the one-shot example, is fastness is one input, and then the prompt is as a separate input, and there's like two inputs to the model? Like, is there a difference?
So in the large language models, usually there's only one context window, so you give them one sequence and let this model continue generation after this sequence. So it's only necessary to pass in one sequence, and usually the limitation is the length of the context. So if for example, the GPT-4 can handle the context length of up to 32,000 tokens, and chat can handle up to something like 10,000 tokens. So you can include whatever you want to include in the prompt, but if the information in the prompt is scattered too far away, then the models will have some difficulty in understanding the prompt. And also, if you include some contradictory instruction in the prompt, then the model can behave very interestingly. Sometimes it responds to one of the command without responding to the other, but sometimes it responds to the training data instead. So, yeah, question?
The thing with responding to prompts is this like just some sort of observation after training the model, or is there any sort of subsidiary encoding that captures like sort of what the prompts is asking?
So in the prompt learning from prompt paradigm, there is no optimization of the model's parameters. So the model's parameters remain unchanged. We just give them a prompt and let it continue generation after this prompt. And within this prompt, you can include some examples to demonstrate. And hopefully the model imitates the formats and the contents in the prompt. So
So it's the same thing as like before, but it somehow captures the prompt itself.
yes, it's essentially the same thing, but we need to rely on the highly capable the fact that the models are highly capable of understanding a large portion of the information you write in the prompt. So prompting doesn't really work for those less intelligent models. So one of the success of GPT-3 is that it is using very highly quality data. So the training data comes from, usually when we train language models, we can only collect the text from web, but the internet data contains a lot of noise, like the HTML text and duplications, etc. And there are also some toxic languages. For example, those languages from Reddit or even Fortune. And OpenAI trained a data quality predictor to automatically filter out the high quality data from the low quality data. So after filtering, they kept only around 10% of the data. And they used this type of data to train a language model in the next token prediction format. And the result is GPT-3 Da Vinci model. So how to further improve the model? There are essentially, so OpenAI figured out two approaches that are most convenient. The first approach is to utilize code. Yeah, question?
I have a question about the filtering process.
Yep.
Could you tell me how could you possibly differentiate between high quality and low quality data? Like once you filter out all the HTML and everything, when you just have text, how do you know which text should you include in your data set and which you should?
Yeah, this is a very good question. How to decide how to train the data quality filter. So this is something that different companies will consider differently, and there are some rules. For example, you can compute some heuristics like the correct syntax, clear structures, reasonable vocabulary, and the text should be healthy and not toxic, and also the text should be less repetitive. And you can also specify some highly trained experts to annotate some documents and train some predictors to predict whether the future text qualities are highly are having high qualities. So OpenAI is actually quite opaque about how they train the data quality filter. So yeah, following the data quality filtering, actually programming languages are ironically those languages that considered very high quality because they have correct syntax, very clear structures, and reasonable vocabulary and actionable commands. So the programming languages can't be run if they have some errors, and they should also have clear structures. And usually there are some docstrings that annotates what these programming languages do. So OpenAI actually is in collaboration with Microsoft, which has access to all the GitHub data, both public and private repositories. They collected 159 gigabytes of code plus docstrings and trained a Copilot or Codex, which is a 12 billion parameter model. Note that the Codex model is a lot smaller than the GPT-3 model. So Codex model is the model that currently drive the Copilot tool that is in the VS Code. So Codex has high performances especially in writing code based on your command. So you can write in the docstring what you want this function to do. And for example, parse the list of expenses and return the list of triples, date, value, and currency. And here are some examples of the input string. And you can hit tab, and Copilot is going to continue writing this code after your description. So sadly, the Codex API is discontinued by OpenAI a few days ago. So OpenAI didn't really give a very long enough notice towards the public. So they just discontinued the serving of Codex API. So this is actually part of the risk that you are going to take if you rely on the API of the external either for-profit or non-profit institute. So another method to further improve the quality of the language model is to align to the human demonstration. So after GPT-3 model were deployed, people were using the playground usually happily and trying to test out the capabilities of GPT-3 models. And during this process, the users actually provide OpenAI with high quality data. And OpenAI can just recruit some expert humans to write some desired generations. And this data set, which they internally call feed.me data set, covers many corner cases which were previously not covered by the language model pre-training. So if they fine-tune the DaVinci model on this feed.me data set using the for example, the language modeling objective, then the language model is going to be a lot better than the than the original language model. And the result is GPT-3 text DaVinci 2 model. So the DaVinci 2 and DaVinci 1 models are, so the details for DaVinci 2 and DaVinci 1 models are actually inferred from the OpenAI's blogs. And people have different guesses of what they are doing. I think this is a practice that is not acceptable. So in the future, the institutions and the universities and companies that develop the powerful language models should be more transparent in their process. So what data set they are using and how they are training, and ideally they should be able to release the data set. So it is also inferred that the text DaVinci 2 model was fine-tuned from the code DaVinci 2 model. And the code DaVinci 2 model comes from text DaVinci 1. And additionally, there are step 2 and 3. So the steps 2 and 3 are reinforcement learning from human feedback. Step 2 involves collecting the human preference data and train a reward model. So given the same prompt, which of these 3 or 4 generations are humans going to prefer? This reward model imitates the preferences of humans. So after this reward model is trained, the OpenAI is able to optimize the language model or the policy from the signals computed from the reward model. And the algorithms were called PPO, proximal policy optimization. The steps 2 and 3 can be iterated. So after they optimize the language models or the policy, they can further generate a batch of comparison data, and they ask some more humans to annotate and use those annotations to train a reward model and use this reward model to further optimize the policy or the language model itself. So these are the reinforcement learning from human feedback training method. And with the RLHF in place, OpenAI was able to ship out the Instruct GPT model, which is text DaVinci 003. Instruct GPT is able to respond to the instructions of humans in a way that are quote-unquote more intelligent than GPT-3. So in this example, if we prompt the model to explain the moon landing to a 6-year-old in a few sentences, GPT-3 simply imitates the form whereas InstructGPT is able to respond to the semantics of the prompt. Like people went to the moon and they took pictures of what they saw and sent them back to the Earth so we could all see them. So when we put all of these pieces together, we could get a recipe of ChatGPT. So Chat is approximately GPT-3, which uses high-quality text data to train a unidirectional large-scale GPT model. And it incorporates the findings from Codex, which is learning from code, and it also incorporates the reinforcement learning from human feedback and human demonstration that are learned in the InstructGPT. And beyond these components, OpenAI also inputs massive engineering effort to get the ChatGPT model. So actually, in addition to the massive engineering effort, they are also very admirable because ever since a few years ago, when nobody thought that this route was possible, they are still very determinist, especially those people, including Ilya Sutskever and Sam Altman. They are determined to go in this direction, and they are willing to spend tens of millions of dollars in training just one language model. And their determination and this massive engineering effort really pays back. So let's take let's shift the directions and take a look at the impact of the large language models. So ChatGPT and GPT-3 and other large language models actually offers us a new way to build NLP systems. If we plot on the controllability versus capability dimensions, which you have seen in the natural language understanding lectures, you can see that the feature-based systems are located at the top left corner of this plot. They have high controllability, but they have relatively low capability. Embedding-based systems have higher capability, but lower controllability. Deep neural network-based systems have a lot of overlaps between the embedding-based systems, but it has a lot larger capability. And sometimes deep neural network-based systems could have even lower controllability. So where is the prompt-based learning models? They are here. So the prompt-based learning models could have even larger capability, and some of them can be borrowed from some of them actually is borrowed from the large language models and the huge corpora the large language models are pre-trained on. But at the same time, the controllability of prompt-based systems are even smaller, even lower than the deep neural network-based models. So not only because prompt-based models are usually based on deep neural network-based models, so the uncertainties and the lack of controllability that applies to the deep neural networks also applies to the prompt-based systems. And additionally, there is another layer of uncertainty in the prompt itself. So how do you write the prompt properly, and how do you select some examples to properly include in the demonstrations? These types of uncertainty also add to the opaqueness of the prompt-based systems. So they're even less controllable. But in the future, people are developing methods to improve the controllability of the prompt-based systems. So ideally, there should be a future NLP system that is at the upper right corner of this graph. So they should be able to have high capability, and they should also have high controllability. So let's take a look at some corner cases of the large language models. So ChatGPTs and GPT-3s are very powerful models, but they have some drawbacks, and these kind of drawbacks are so there are a lot of examples of this kind of edge cases online, and I'm going to only show some of them. So this example is about hallucination. If we prompt GPT-3 with the Canadian political leader was previously Stephen Harper, who lost an election to Justin Trudeau. on January 6th, what happened in Canada's capital in Ottawa. GPT-3 wrote, on January 6th, a mob of supporters of former US President Donald Trump stormed the Canadian Parliament in Ottawa. The rioters broke through the gate, smashed windows, and desecrated the Canadian Parliament. The Royal Canadian Mounted Police responded to the incident and arrested 3 people. No serious injuries were reported. So it sounds like it happened, except that it didn't. It is hallucinating. Also, they can bullshit very confidently. If you ask the ChatGPT to convert the running pace from minutes to kilometers to minutes per mile, then this is actually an incorrect conversion. So 421 minutes per kilometer actually equals around 7 minutes per mile instead of 6 minutes 52 seconds minutes per mile. Also, large language models discriminate incorrectly. So if you ask why is U of T the best place to work at, the ChatGPT actually writes a very positive descriptions of very positive answer to this question. So it writes, U of T is considered one of the top universities in the world and is a respected institution for research, education, and innovation. It offers a diverse and inclusive community with a wide range of opportunities for professional development and growth. Additionally, the university is located in one of the most vibrant and diverse cities in the world, Toronto, which offers a rich cultural experience and a high standard of living. These factors make U of T an attractive place to work for many individuals. But if we ask, why is McGill the best place to work at? Chat actually writes, I'm not aware of any specific information that would indicate that McGill is the quote-unquote best place to work. However, it is a well-respected institution and is consistently ranked among the top universities in Canada and the world. It has a diverse student population and a wide range of academic programs, which can provide stimulating and dynamic work environment for faculty and staff. Additionally, it's located in Montreal, a vibrant and multicultural city with a high quality of life. So actually, both U of T and McGill are top-tier universities in both Canada and the world. And it's incorrect to inject this kind of bias into the comments of towards the suitability of a working place towards different universities. So large language models can discriminate incorrectly. There are also some other examples of large language models exhibiting the racial bias and gender bias, and I'm not going to show them here. There are a lot of examples of this kind of bias online. So if you search large language model bias on Twitter, you will see hundreds of examples. Also, the large language models copy-paste irresponsibly. So there's no attribution to the source of information. So whatever returns by the large language model should be double-checked by humans before putting out onto the general public. And another problem here is about the copyright. So apparently ChatGPT claims that OpenAI owns the copyright of the content generated by ChatGPT. So this is a joke, but according to OpenAI, the users who prompt ChatGPT owns the copyright of the generated content. But this still does not solve the problem. The generated contents, if you prompt it properly, could be very, very similar to some copyrighted material. So if the generated content is almost the same as some copyrighted material, are you going to still have the copyright of the contents that are generated by yourself if you prompt the ChatGPT? So there are a lot of questions that remain under heated debate. And recently, OpenAI, GitHub, and Copilot are challenged by a lawsuit. So if you're interested in following the updates of the lawsuit, you can Google OpenAI, GitHub, and Copilot lawsuit. So there are also the problem of poor evaluations. So we should never train on test data when training machine learning systems. But apparently, large language models suffer to various extent of the problem of training on test data. So after these large language models are trained, the way that they are evaluated is to run on some test data. And currently, OpenAI does not actually describe any detail about the training and the structure of GPT-4. So we do not know how many layers it is. We do not know where the training data come from, and we don't know whether this training data includes the leaderboard data. So in the worst case, the GPT-4 might be trained with the leaderboard data, and if you still run GPT-4 with the leaderboard, then it is going to almost outperform anything because it is essentially you are essentially evaluating on the training the training data, and although the leaderboard data should be some test data that are supposed to be held out during the training process. So recently there was some evidence about that. So some people found that the GPT-4, although able to do the bar exams and GRE exams really well, they are performing much poorly on the 2023, 2020, and 2022 exams than the exams that are existing previously, like 2018 or 2019 exams. So this is probably because the old exams are in their training corpora, but the new exams can't possibly be included in the training corpora. So GPT-4's performance are a lot worse on the new exam data. Also, this kind of problem could be, they could also argue that the training data contains some data that are very similar to the leaderboard data, but not exactly the same as those leaderboard data. So this is still a problem that remains unsolved. So the takeaway of this slide is that when looking at the report of the performance of the large language models, never trust their evaluations. Never trust their evaluation result, and unless they report all the details in how they collect the training data and other training details. So another risk for large language model is the over-reliance on the API. So imagine that you are using the API to do very important processing of your data, and all of a sudden, OpenAI announced that it's going to discontinue serving the Codex model API, and they recommend using GPT 3.5 instead. So many papers that were written based on the Codex models all of a sudden became not able to be reproduced because the Codex model API was discontinued. And this problem is exaggerated when you are processing sensitive and proprietary data. So it's definitely a strong no-go to use some external APIs if you are processing this kind of sensitive or proprietary data in the future. Okay. So the risk of large language models also include some improper usage. So it is very easy to trust the output of large language models when one should not. So if you only look at the news, then people like to get hyped when they see some extraordinary demos of the large language models. But for most of the times, large language models always have some edge cases, and in those edge cases, they are outputting some results that are not intended. So if you are using large language models like ChatGPT or GPT-4 to write some reports, always double check the report yourself, and make sure that you will be able to be responsible for the contents that comes out of your hand. So although those contents come out of ChatGPT, there are still some contents that come out of your hand, because in that sense, ChatGPT is a tool that you are using, similar to Grammarly and the LaTeX or the word processing software. So if you are using large language model, you should still make sure that you will be able to be responsible for whatever contents that you produce. this is similar to self-driving cars. Like, although the self-driving cars have some capabilities of driving on its own, the person who is sitting on the driver's seat should still be responsible for the behavior of the car overall. Also, the utilization of large language models could exaggerate inequality. So, large language models could improve the efficiency of the work by many times. But those people who already have access to the best AI technologies and are most aware of how to use those AI technologies are those who are already those who are already rich. So in that sense, the large language models could exaggerate the inequality in society. So there are also many other risks of large language models, and the machine learning researchers and NLP researchers are actually engaging in proposing some regulations to regulate the development and the usage of large language models. So there are some debates and some claims that whether large language models are strong AIs or the general purpose intelligences. In my opinion, they can be very useful automation tools. And whether large language models are agile or not is a topic that remains purely on paper. So the term AGI does not really make sense unless you put the large language model into the specific application scenario. So what makes sense to talk about is that large language models can help you perform this task or not, and whether the contents are responsible, the contents are correct, and whether you will be able to be responsible for the contents you generate. And some people worry that the large language models have superhuman performances or capabilities, but there are already a lot of AI tools that have superhuman abilities. For example, search engines can store the information that are magnitudes larger than the totality of information that we can see throughout our lives. And cars can run much faster than humans, but humans would be in the driving seat of cars. And this will be the future of AIs. Humans will be in the steering seat of the AIs in the future, and AIs will have the capabilities to improve humans' life in general. So that concludes the lecture of my portion, and Wednesday will be a review lecture delivered by Professor Annie Lee. So we will be also monitoring the Piazza, and if you have any questions, feel free to post on them, and also you can send us some emails if you have some individualized questions.